Hello, everyone. Welcome to the second webinar in the MIT Africa Lecture Series. My name is Vivian Chinoda, and I'm the Vice President of the African Students Association. The African Students Association is a community at MIT that celebrates African excellence and fosters a welcoming community of diverse students that are interested in African culture. We have a variety of programs like the African Learning Circle, which is a forum for students to talk about innovation and academia and how they can impact Africa in problems that have existed, are there today, and that we foresee. And we're delighted to be collaborating with the MIT Alumni Association and MIT Misty Africa program on this webinar lecture series featuring lectures by 4 MIT faculty members discussing their ongoing research activities in Africa. Topics covered during this series include last week's lecture on the built environment and urban politics in Africa, today's lecture, Rethinking Nuclear Energy Solutions for the African Continent, and there are also 2 sessions coming that are collaborating on space-enabled designs with African leaders on the 1st of May, and MIT Africa engagement in the 21st century challenges and possibilities on the 8th of May. Before we begin, a quick housekeeping note. We encourage you to submit questions in the Q&A box, and we'll try to get as many as possible during the question and answer section after the lecture. So without further ado, it is my pleasure to introduce today's speaker, Professor Ericmoore, Jossou.
Thank you, Vivian, for the kind introduction, and thanks for the kind invite to share on my research, and also to provide some perspective on nuclear energy for the African continent. So I'm gonna go ahead to share my screen. Can everyone see my screen? Just maybe a thumb up or something like that should do. All right, so I think this works perfectly fine. Just move this to the side. All right. Okay. Yeah. So today I'm going to just share my thoughts on nuclear energy solutions for the African continent. It's been long coming. We've had a lot of efforts in many years past on trying to have nuclear reactors run on the continent. And growing up as a child, it was almost like a taboo to talk about a nuclear reactor because what comes to mind is always the idea that this is not safe. And given our history as Africans, we are not in a position to handle such a technology. So growing up as a teenager, this stayed on with me. And to further um, explain this idea, people like me never thought about doing a degree in nuclear engineering because the question is if I study nuclear engineering or if I get a training in nuclear science and engineering, where do I use those skill set? So it's not even really in most of the African curriculum. Just to give a context for where we're coming from and why it is important to begin to rethink how we deploy nuclear reactors on the African continent. Uh, for some reasons, because as a child, I experienced a lot of energy deficient in my own environment. Um, we usually will have maybe a couple hours of electricity every day, or sometimes for weeks, you may not even have electricity. So it's always put me on that path to think of how do we solve this solution? How do we solve this problem? And so the research that I do in my group is strongly tied to providing energy solutions in ways that can fast track the production of green and sustainable energy for the African continent. So my group is called the Materials in Extreme Environment Lab. Rightly so, because the materials we use in nuclear reactors, they are usually in very extreme environments of high temperature, radiation. And so because of that, we are always trying to design materials that can withstand those environments. And so what my lab does is really to leverage modern computing resources to be able to predict the properties and behavior of materials at conditions that are not accessible by experiments. And so once we're able to do this sort of predictions, it helps us to cut down cost of making new materials or discovering new materials. So we call it a rational guide to materials design and materials discovery. And so very specifically, I work a lot on nuclear fuels and also nuclear claddings, and I'm going to explain a couple of these terms as I go on in this talk. And also because we have advancement in methods and techniques that allows us to be able to see materials at nanoscales and at atomic scales. Now we have access to state-of-the-art tools to be able to probe these materials even under working conditions. And so my lab really developed some of these techniques and also some of these environments in a way that allows us to be able to visualize them uh, using state-of-the-art techniques that are almost not available in the rest of the world. Um, so what do? We leverage a lot of artificial intelligence to be able to design nuclear fuels and alloys. So the idea is that alloys compositions are very vast, and so it's like you looking for a needle in a haystack. And so to fast track that process and make it easy for ourselves, we employ machine learning models to be able to very quickly go through that proverbial haystack to be able to find the needle, which is usually finding the right composition of elements that give us the desired properties for specific environment, and in this case, for nuclear reactor environments. And because when you put these materials in reactors, uh, they degrade very quickly over the years, and so the starting point of those degradation is always defects that are generated. So we invest a lot of our time into X-ray imaging techniques that allows us to be able to identify these defects and able also to slow them down. And the other very important things that we also do is that rather than just depend on experiment, we employ a lot of physics-informed types simulations to be able to predict the properties of these materials in extreme environments. And so this really put us on the pedestal to be able to design materials very quickly. And so we no longer rely on serendipity to design or discover materials. And so that helps us to now rethink the materials that we put into the design of nuclear reactors, because back in the days when reactors were first designed, these sorts of tools and techniques were in their infancy, but now many of them are really mature, and so we can really rethink how materials are selected for the design of nuclear reactors. Uh, Also very important is the fact that we focus a lot on nuclear fuel design, which is really the materials, which is the fissile material, the radioactive materials that is able to uh, participate in a radioactive reaction and then generate the energy that is able to provide the heat to heat up water to be able to generate steam that then generate the electricity. And so fundamentally, we try to understand the behavior of these fuel materials and also to be able to design them in a way that they are accident tolerant. And what that means is that when an accident occurs and we lose all the water in the core of the reactor, uh, that reactor shouldn't explode immediately. It should give us some coping time to be able to provide safety for people and to also shut down that reactor. And so my group spent a lot of time on developing methods and techniques to enhance the properties of these nuclear fuel materials. And one of the things we try to do is to tune their heat generation properties through by tuning their thermal conductivity, which allows them to be able to efficiently dissipate heat The other thing we also try to do is just by improving on their manufacturing uh, techniques in a way that allows us to be able to just improve their microstructure, because we realize that by just improving microstructures, you could almost improve the properties of these materials. For example, you can allow them to be able to retain more of the fission gases that are produced during radioactive reactions. The other thing we also try to do are super fundamental, where we really try to understand the behavior of these fuel materials while imaging them using X-ray techniques. So why this is very fundamental, with some semblance of applications to reactors around the world, I would like to share a little more about the reason why it's very important and almost a matter of urgency for Africa to begin to rapidly deploy nuclear reactors, generate energy from nuclear reactors for its daily consumption, for civil use, and also for industrial use. By way of starting in this direction, it's important to provide a motivation for why this is important. One, from what we are told from the UN, human beings need at least, every human need about 3,000 kilowatt hours of energy per year to be able to live a good or decent life. But it turns out that about 70 billions of the world populations have access to less than 3,000 kilowatt hours. Even more shocking is the fact that the whole continent of Africa, if you do the distribution, each individual gets less than 400 kilowatts hours per year. So it makes us the energy poverty continent of the world. And what I effectively mean is that because we do not have access to these clean electricity sources, we turn to other means to be able to provide energy for our own use. And these two pictures remind me of my own self when I was a teenager living in the suburb of Lagos. And I'll remember that when the electricity goes away, what will happen is that you will use this. On my left, you have this fancy lantern. It's quite fancy in that sense. I didn't even know I could find a picture of it. And you put it on, and it has this very nice stopper on top of it that helps to screen out the smoke so that the smoke doesn't get into the environment, right? And on the right, you have the little more crude one that you could almost locally make yourself, where there is nothing really filtering away the smoke. And what I effectively mean is that when you stay using this sort of lantern for a while, and you take uh, some toilet paper or whatever, and you put it in your nose and you dap your nose and you bring it out, you literally can see this smoke laced um, thing on the paper, right? And I tell you this story because I have experienced it. And so beyond just doing this research in my own lab, I have personal connections to the stories of the energy poverty that that ravage our own continent. And to also put this further in perspective is that what we now do in the modern day African continent is that almost every household has this very small generating electricity generating set. So once the electricity provider takes it away, everybody puts it on. And so what you do is that you have to exchange noise for darkness, right? Everybody puts it on and the whole place becomes very noisy, right? And then you have some semblance of electricity for a couple of hours using this set. So we are in dire needs of improvement in our energy solutions. And for me, given the energy density from nuclear reactors, it's really the way to go for us. And given the fact that it leaves minimum or no carbon footprint on the environment. And on my right, I have this chart that shows the Human Development Index that says that to be considered living a good life, you should be at least zero 0.8 and above. And so you have countries like the US, An average American have access to 12,000 kilowatt hours of electricity per year, just to put that in context. And you have countries in Europe having more access to this electricity. And then by the time you go to the left and look at that belt, the further down you go, you see countries like Niger, you see countries like Ethiopia, you see countries like Angola, you see countries like Nigeria, you see countries like Ghana. And so effectively, what that means is that we need to really think uh, how we generate electricity. And now, right now, our source of electricity is mainly from gas-fired turbines and also from hydro, where you literally just you damp a river and then you are able to use the pressure from that to be able to drive a turbine. And you have a couple of those around the continent. But more importantly, most of the countries depend a lot on gas-fired turbines and also on coal. In fact, the whole of the eastern part of the country tends to use coal, and that's because it is cheaper to set up a coal generating set, and so people tend to go for these options, even though it is quite dirty and expose people more to very risky environmental impacts. And it turns out, if you look at these charts, that South Africa is about the only country on the continent that generates 5% of its electricity from nuclear energy sources. So they have two nuclear reactors that generate about 950 megawatt of electricity. And so in that sense, they are the leading light on the continent. And right now, a country like Egypt is also currently building a nuclear reactor that we hopefully should come online in 2027 or thereabout. And so there is a dear need to diversify the source of our electricity. And again, if you look at this plot, it could be misleading because it doesn't really tell you the full picture of how much energy we are able to generate as a continent or how much energies that we generate as a country. And to put that in perspective, Nigeria, which is the country that I'm originally from, um, those populations are not correct. These were as at 2019. So right now, the population of Nigeria is about between 200 to 220 million people. But what remained constant even now in 2024 is that we still generate about 4,500 megawatt energy to serve about 220 million people. And what is true in South Africa is that the population is now about 60 million, but the electricity supply is is still about 46,000 megawatt, which is about the highest on the continent. So they sort of enjoys a little more electricity than the rest of us in Africa. If you look at a country like Ghana, the population right now is running close to 30 million. Um, but the generation is still about 2,000 megawatts. So if you put that in context, Ghana, with that populations, they now have like staggered supply of electricity for their population. But a country like Nigeria, with over 200 million people running on 4,500 megawatt, is barely able to provide electricity for its whole population. There are places that have never seen electricity. There are places that maybe in a week it gets just about an hour or 2 hours of electricity. So truly, the continent is really uh, the energy poverty capital of the world, if you ask me. Now, enough about the problem. We know the problem. We know that we are in their need of a solution. Just to put things in context, in comparing nuclear energy to other energy sources around, if you have one pellet of uranium, which is like the fuel that we use in the reactor, which is about 1 inch tall, the energy is able to provide is equivalent to 17,000 cubic feet of natural gas. So imagine how much spaces we need as Africans to be able to fire those gas turbines. We need so much more. If you think about oil, it is equivalent to 120 gallons of oil, what you are able to extract in terms of energy from one pellet of uranium. If you think about coal, you need about 1 ton of coal to be able to get an equivalent of what you get from one pellet of uranium. So what that means in a nutshell is that nuclear fuel provides an extreme energy density that if properly utilized can serve a continent that is highly dense. It's very important to take note that we've been told that by projection by 2050, Africa will be responsible for about 40% of the world population. So that is a country that is really heading towards highly dense population. Already dense anyways, but it's going to become extremely more dense. And effectively, we need to quickly think of solutions that provide energy for the people. And the reason why this is important is because uh, availability of energy clearly is very has been linked to one, the quality of life, has been linked to industrialization, has been linked to human capital development. So effectively, for us to grow as a continent, we need to be able to meet our own energy needs. So this is really very important. Now, the next thing I'm going to show is that how does nuclear energy really, how does this work? So we have nuclear fission and we have nuclear fusion. So right now our nuclear reactors operate based on fission, that is small atoms comes together. So, a big atom breaks up into smaller atoms and then they produce energy. For fusion, small atoms come together to fuse, and when they fuse together, they provide energy. So I'm going to play this about 1 minute of a video to just provide what this looks to everyone so that you have an idea of what I'm talking about. So that is in 1 minute. That is the whole summary about nuclear fission and nuclear fusion. So in principle, fission is what provides the energy we use right now. There's a lot of work going on to also make fusion reaction happen. But because of the extreme temperatures at which they occur, we have a lot of materials issues to deal with, and a lot of people are really working in direction. And MIT happens to be one of the leading lights in this area, been able to spin out a startup called Commonwealth Fusion that is doing an amazing work in getting us closer to having fusion reactors um, come online. And so that's the basic reactions that provides the heat that is generated in the reactor. And so where you have those control rods are where you have the fuel. And so when I talk about the nuclear fuel pellets, those very dark cylindrical rods over here that I point to are what you call the nuclear fuels. Usually they're made from uranium dioxide. And so we then put them into these channels of what we call claddings. So these claddings, they protect the fuel from coming in contact with water and so on. And so an area of active research that we focus on a lot is trying to improve the properties of these clad materials to be able to protect the fuel properly. And also we try to understand the interactions between the fuel and also the cladding. And so that forms an area of open research that keeps going on, because the better we understand them, it helps us to be able to protect the fuel from reacting with the cladding. And so you have the reactor right there, which is able to provide the heat and that it's carried in pipes to a secondary containment where that heat is able to then heat up water, and that water generates steams that then drives turbine, and once that those turbines are driven, they are able to generate electricity for society. And one key area that people have really had concern about over the years has always been the safety of nuclear reactors. But I'll just put it to you that in the history of civil use of nuclear reactors, we've had, uh, depending on who you ask, but if you ask me, you've had two major accidents. The third one never really happened. The 3 Mile Island accident never really completely happened, in my opinion. Um, the other one is Chernobyl in Russia, which was mainly due to human negligence. And the most recent one is Fukushima in Japan in 2011, December. And that was because there was a tsunami that knocked down the reactor facility, and then caused a breach to the reactor, and then we lost the coolant, which is the water that sort of cooled the reactor. And because the coolant was lost, and there was still continuous generation of it, then reactions between some of the water and and zirconium caused this big explosion that took place. But then, because of that accident, we've done more research to be able to improve the accident tolerance nature of the fuel, which is pretty much the track of research that I do, making the reactors even safer than they've ever been before. So, in my opinion, there shouldn't be so much worry about accidents and also the safety of these reactors, because we really take that very seriously. And putting that in context, France as a country gets 70% of its energy from nuclear reactors. The US get about 20-25% of its energy supply from nuclear energy. And so this has been around, and we've used it for many years. So the technology is well understood. And so as a continent, for me, this is really the way to go. So now, what is the current state of art? What is the directions that the continent is moving on? So IAEA, which is really the global regulatory body, has put together a pathway for any country that is trying to develop a nuclear power program. And so those are contained in like three phases. And so the first phase is really you making this decision and start to do exploratory work about what you need to, about having a nuclear power launched and situated in your country. And the next phase is always to do a lot of human capital development, training people to be able to handle the plants, talking with vendors, and all of that. And this could take between 10 to 15 years. And so it's important to point out that in Africa right now, with the exception of South Africa that already have two reactors running, and Egypt that is already building one, Ghana and Nigeria at phase two, where they have put policies together. They are speaking with vendors and trying to get. They already identified sites. For example, in Nigeria, they've identified two sites. One in a place called Akwa Ibom, and one in the middle of the country called Kogi State, to locate these two reactors. So what is currently happening is that there's a lot of behind the scene um, talks going on between countries that wants to provide these resources. Uh, the Chinese are coming around to get to be able to provide these reactors. The Russians are also coming around to sign agreements to be able to provide this reactor. But the country that have made a lot more emphatic decision on what direction they want to go with is Ghana. So Ghana have decided to get their supply, their vendors from the US. So they have this very strong relationship with the DOE, able to set up like meetings. In 2022, there was a US African meeting on nuclear energy that was hosted in Ghana to be able to get other African countries together to get commitments towards a path to provide these nuclear reactor resources for them. And so one of the other key important thing is that why at this phase it's very critical to then begin to develop like curriculum and university programs to be able to train students uh, in nuclear engineering. And Ghana has made that commitment. Now they have a master's program in nuclear engineering. They have a PhD program in nuclear engineering, and they are about to start an undergraduate program. For Nigeria, Nigeria is a little bit behind on that. The best they've gotten is usually send people abroad. So some of these countries that wants to provide these reactors will offer scholarships to some of the people to come study nuclear engineering in their country and then go back. And so this has been going on. And in my opinion, since I've been a little child, this cycle continues. There is usually this enthusiasm that, oh, we are going to do nuclear. And then they get some commitment from some partner in the West. And then for about 5, 10 years, everybody becomes very excited. People get scholarship to go study nuclear engineering. They come back and then the cycle stops and then it starts all over again. And then so you realize that a country like Nigeria could be stuck in phase two for almost forever, if I may say, if we don't change how we really think about doing these things. And this is where I talk about the fact that this may be another Berlin conference, right? Because in 1884, there was a Berlin conference where all the European countries came together to decide how to trade in Africa and what country goes to which European country. And so, in the absence of Africans, the continent was shared among several different countries in Europe, such that a country like Nigeria went to Britain, a country like Togo, Benin Republic went to France. A country like Cote d'Ivoire went to France. A country like Congo went to Belgium, and that country almost became like the personal estate of King Leopold for many years. And so, in my opinion, what I'm seeing and I sense is another repeat of the same idea, right? And now, why do I say that? In the American Nuclear Society magazine, we call it Nuclear News, in December and also in March 2024, a lot of the write-up were devoted to having Africa get nuclear energy, right? And a good chunk of interview was done with a couple decision makers in Ghana because they are very clear they are going to go with the US in terms of meeting their nuclear energy reactor needs. And so this is going on, and also a very strong bilateral um, position has been taken between Ghana and the US in terms of providing the resource they will need to get this reactor set up. And so there is really a lot of us trading going on at the moment to be able to get to that point. So really a lot of activities, a lot of wooing going on from the West to be able to get themselves positioned what countries they are able to provide these reactors to. And sometimes what I ask myself, are these intentions, are they completely altruistic? Maybe, maybe not. And I'll tell you the reason why I think that way in a little bit. I'll tell you why I think like that in a little bit. So what I think in my own opinion is that we need to uh, change how we think about meeting our nuclear energy need. We have to begin to think of how to uh, use our own local resources to be able to build these nuclear reactors on the continent. We have to start to train our own people to be able to build these reactors. It's very important to know that around the world, we have a lot of leading African nuclear engineers and scientists whose brains we can tap into to be able to um, work with folks back at home to be able to do these sort of designs and develop them. Because what I've found is that if you don't design them yourself, we are going to completely rely on the provider to be able to talk you through if you have any problem with the reactor. And how do I know this? If a rail line breaks down in Nigeria, that rail line may have to wait for a couple days, couple weeks until the Chinese arrive to fix it. Why? Because the Chinese build a rail line. In my opinion, we need to begin to use our own local contents to begin to build our own infrastructures. And so that really got me thinking about how can I walk the talk? So I decided to try this idea of MIT Africa handshake. And what I effectively mean is that on a very small scale, we can add value to some of the resources that are be very critical to designing a nuclear reactor. And so what these two gentlemen here has done, Tabiri and Desmond has done. Tabiri is from Kwame Nkrumah University of Science and Technology. Desmond is from University of Witwatersrand in South Africa. So what they've intelligently do is to use one of our staple called cassava. So cassava, for context, is a staple in Africa. Is our own version of where we get our own cereals from, which is one of my favorite cereals, even up till date. And I think I've gotten my own daughter to also like this particular cereal as well. So what happened is that we are able to use the tuber to be able to make cereals. We are able to use it to make them into dough. We've been able to almost use this to make bread as well. But what we've never tapped into is what happens to the leaves. So what this gentleman has done is this idea that has been around for a while, that was pioneered by a professor of mine back in the days. Professor Adewa is now late. And the idea is to use these leaves as source of carbon to be able to protect surfaces of metals and steels, right? And so the idea is that if I'm able to protect these surfaces, I can prevent further corrosion. And this is a very important problem that we have to deal with when we make these claddings. We want to really reduce corrosion, right? And so these gentlemen find very intelligent way of pulverizing this leaf after drying it up, mixing it up with barium carbonate. And with that, they were able to then, at high temperature, use these as coatings to protect metals from further damage. And the results they found were quite interesting. One, these have a properties that we call a super lubricity. That is such that the friction between the coating and any surface is almost close to zero, which is super important for designing materials where you need them to be frictionless. And beyond that, the strength of these coatings are super great. And what I effectively mean is that we could almost explore them for nuclear energy application. And so thanks to Misty Africa, we just got this generous funding from them to be able to explore the radiation resistance of these coatings. And so the idea is that if the radiation resistance is great, then we could really start to think of them and use them as coatings for nuclear structural materials, for nuclear reactors. Even we could almost extend them as coatings for the claddings that protects the field. And so a couple of things that then needs to happen is that as a continent, we need to begin to think of adding values to our own resources. And why is this really important? And this is the point where I tell people that I really have strong opinions about this thing. Niger is a country that has the fourth largest uranium deposit in the world. But it's shocking to let you know that the very town from which this uranium is mined is in utter darkness. So a lot of these uranium is mined in Niger, but it's interesting to know that Niger does not have a nuclear reactor to provide energy. And the value that this uranium is exchanged for is just for a partridge son. Why? Because values are not added to them before they are taken out of the continent. And some of those villages where this uranium is mined from, people would die of what they call strange diseases. But what we have found is that there is a link between the mining site and the death of these people. So the environmental impact is there, and also values are not added to these materials. And strongly linked to these, the poverty along this belt now is an unstable government. In the last 3-4 years, there have been about 4 military coups along that Sahel region. Niger is one of them. Gabon is one of those countries that has also joined as well. And so you have this instability along that whole region. Why? Because there is extreme poverty in those places. And we do know that the poverty is strongly linked to the energy poverty that is in those countries, that is also generally on the continent. And so the way to think about these, and the way to go for me, is to just add values to these materials on the continent. Another very important materials that we also need to add values towards our path to nuclear energy is our iron ore. And one of the largest deposits of iron ore is found in South Africa. And it gladdens my heart that South Africa is able to do a large chunk of the processing of these iron ore, because the process for iron making has been around for thousands of years and is fairly well known. And so they have a couple steel making industries. But beyond South Africa and a little bit of Zimbabwe, many of the African countries with iron ore are not able to refine them. What happened is that many of them are shipped away, and in cases where they are not shipped away, the case in point, Nigeria, nothing happens to them, because for many years, at least in the last 20 years, the steel mill has not worked, but the workers in the steel mill are still being paid. Those that are retired are still being paid retirements. But that steel mill has not worked for over 20 years. Think about that. And then, very importantly, is that industrialization and development is strongly linked to our ability to be able to refine and produce our own steel. Because ability to produce then allows us to be able to provide structural material for building these reactors. But then, how do we get ahead of this curve while we begin to add values to our own resources? The way to get ahead of this curve is for us to, rather than try to build traditional big nuclear reactors, we can think of building and using these new reactors. We call them microreactors or modular reactors. They are super small in a way that they can fit up on top of a truck, such that they can be manufactured and transferred to that site, right? And so what that effectively means is, just like the way as Africans, we can order a car from the US or from Europe, and then it's shipped to us over the sea. We can, in principle, order a modular reactor, and then it's shipped to us over a couple of months. And then on site, everything is just plugged and play. And then communities can be connected. And what I effectively can do is that very hard to reach communities can now begin to use these modular reactors to be able to meet their energy needs. And so that effectively allows us to be able to generate clusters of energy of energy sources in ways that by the time you combine them together, they allows us to be able to reach our energy needs. And for me, this will be a direction for us to go. And like I've pointed out, the next steps will be for us to, one, prioritize human development in nuclear science and technology. Many of our universities need to begin to set up nuclear science and engineering programs, with the exception of Egypt, that have had a long history of nuclear engineering programs which has been very successful. Many of the other African countries now needs to begin to go in this direction, which is very important for the phase two that is required for the IAEA for people to be able to provide nuclear energy as a means of generating energy for their continent or for their country. And very important to point out that we need to focus more long term on this homegrown solution, which for me is a road less traveled by Africans. We really like plug and play type solutions, but for us to really have a sustained development and for us to be able to meet our energy needs in the long term, we need to travel this road on our own. We need to use our own resources, add values to them, and from ground up build our own nuclear reactors that will be able to power our homes and our industry. Is this impossible? No, it's not. The technology has been around for many years now, and so it is fairly well understood. And all we need to do is to just go by the book and use the existing technology to be able to build what we need for our own continent. And very key in this conversation is the African Commission on Nuclear Energy, who has been the go-between for the region, for the continent, and the rest of the world. And in my opinion, they need to do more. This is me really just calling them out. They've been around for a couple years now. And the only thing I keep hearing from them is signing MOU all over the place. Beyond signing MOUs, we need to really see boots on the ground. We need to see reactors being built. We need to see houses being powered. My children should be able to visit Nigeria and have 24-hour supply of electricity without us depending on a generator. Every time I want to take my kids to Lagos, they ask me, Dad, are we going to have electricity? So in the next couple of years, I want to be able to tell them that you can come to Nigeria, you will have all the electricity that you will need. You can watch your Netflix without batting an eye, without loss of electricity. I want to be able to say that to my kids. And so the AFCON needs to effectively begins to provide real solutions in terms of bringing critical mass of African scientists in diaspora, and there are lots of them all over the place who are truly contributing to meeting the energy needs of the rest of the world that can use these skills to be able to also build lasting energy solutions for our own continent. And so at this point, I'm going to stop and then take questions if there are any. Thank you.
All right. Thank you so much, Professor.
Thank you.
Great talk. A lot to think about there, especially the opportunity to work with these sort of modular designs to rapidly deploy. But we had some really interesting questions from the alumni. So let me get to them. So first, and I apologize if I don't get to all of them. First, we have a question from Jeffrey. Thanks again, Jeffrey, for joining. Are there special infrastructure issues to support nuclear facilities in countries that are looking to build them? We mentioned, of course, South Africa, we know, but also Ghana, Nigeria. And if there were reactors in those countries, what would be the issues related to handling nuclear waste, and who would be kind of best suited to deal with the nuclear waste in that sense?
Okay. That's a really good, very good question. And dealing with nuclear waste is always a big part of the reason why many countries try to hold back. But if you think about it, in the US, in Japan, and the rest of the world, we find very intelligent way of holding this waste in geological repositories. And beyond holding them in repository, we are also developing new ways of reprocessing this waste to be able to get new fuels from them to use for the reactor. And so in couple years from now as well, we will be able to have a whole complete closing the loop where you can go from the waste back to the fuel, and then that cycle continues. And so that continues to be an active area of research. But in the short term, what we always have to do is find the site for storing them, and also training the human capital to be able to handle them. And just to be clear, we've got a couple of research reactors on the continent, and so far people have been able to handle them responsibly well. So just think about having a powered nuclear reactor as a scaled version of a research reactor. And so we are not completely inexperienced in how to handle them.
Okay, thank you. Next question from Keith Alverson. I'm enjoying this presentation. Thank you. Waste to energy is an electrical generation technology far simpler and safer than nuclear, which is widely adopted in Europe, North America, and parts of East Asia. That appears that it should be relevant in much of Africa, but it has not been adopted for the most part. And where a plant was first installed, in the example of Ethiopia, it failed almost immediately. Can you comment on why waste to energy is not working in Africa? And if this relatively simple technology has not been adopted, what would be the benefit of going to something more advanced like nuclear?
Okay, that's a fair question. Waste to energy. So I think that a lot of time it still goes back to culture and to commitment, right? And the idea is that we usually start out things with a lot of zeal, right? We want to get it done, and then we do it halfway, and then everything falls through. And so that's why I talk about rethinking about these solutions. That's why I talked about uh, changing the culture. That's why I talk about the need for us to, rather than just drop MOUs about them, we need to have strong stance about them and follow them through. And so the same thing goes for going from waste to energy. Africa generates some of the largest amount of bio waste in the world. Okay, just to put that in context, we generate some of the largest amount of bio waste in the world. But rather than make energy of that, they become nuisance in our environment because we are not committed to building the infrastructures that helps us to take those waste and turn them to energy. But to also say something a little positive, a city like Lagos, which is very dear to my heart, has done better in handling waste and taking waste to energy. And they've got about, I think, 2 or 3 bio waste processing plants that is able to take them, churn them, and turns them into some semblance of energy. And the very important thing that is happening to them now is that ability to generate energy used to be the exclusive right of the federal government, and this is very pervasive across the continent, right? And so that makes it very difficult for the municipals and for the provincial governments to be able to develop and deploy these small-scale energy solutions like waste to energy. But now many of those countries are beginning to unbundle these policies to allow many of the states, many of the provinces, and many of the municipals to be able to become energy independent. So looking forward, I will say that in the next couple years, I think that more states and more within the countries are going to be able to independently provide their own energy solution from things like waste.
Thank you. Okay, I think we have time for one more. Let's from Peter. Why have SMRs not been deployed in more places? And what are the limitations on urban deployment? I think from an infrastructural perspective, perhaps, and such as distribution limitations. And what are the cost considerations? You know, when versus rapidly deploying maybe wind or solar,
Right.
and other lower cost, more established options.
Okay. So one thing we do know for SMR is that the economy of scale at the moment is not very great, to be fair. But what I effectively mean is that when we can mass produce, right, then we can pass on the cost. And because they are still in their infancy in terms of development, the cost doesn't look great, and that's discouraged a lot of people from using SMRs. But what the future the future outlook for SMR is that many more countries are going to begin to adopt them because you are able to very quickly provide energy solutions for very hard to reach communities. And so once this picks up and more countries and more users come online using them, then the cost will drastically can spread across. And once that happens, then it becomes more feasible for more people, more countries and more people to use it. But one very important thing to point out is that Africa shouldn't be late to the party. It's very important to tag on and get on the bandwagon of using SMR right now than wait another 10, 15, 20 years to get on it. At that point, we'll be late to it. Early adoption allows you to learn the technology very quickly and very fast. So I encourage that African government policymakers think very strongly about SMR than even the traditional reactor, even if it is more expensive, because in the long term, the cost is going to spread out.
Okay, I think we're out of time, but thank you so much. I'll do some clapping on behalf of the participants today. Thank you, of course, Professor, for joining us. Thank you to the Alumni Association, all the alumni for joining. Thank you to Vivian from the African Students Association. We'll be back next week, same time, same place, with a lecture from Professor Danielle Wood on space-enabled designs and working on space-enabled designs with African leadership. So thank you all. Have a wonderful week and see you next week.
All right. Thank you for having me.
Thank you.